All right then. Welcome to my Lab 0 tutorial, in which I'm learning how to use digital and learning how to use GTK Wave. In this tutorial, I am specifically using an XOR circuit. I'm going to be demoing an XOR circuit on my digital. Over here is a picture with me and the UGTA from the Goldwater 273 lab. So here is my circuit. So as we can see over here, this is supposed to represent an XOR circuit. An XOR circuit is an exclusive OR circuit. Essentially, it will only turn on, Y will only be on if either A or B is turned on. If both are turned on, Y will be off. If both are off, Y will be off. So here's what we can see. So if I just turn on A, as we can see, for this AND gate, in order to register, we need both OR gates to work. And as we can see, A OR gate only needs either or. So either A needs to be on or B needs to be on. And this works for this OR gate over here. And we can see for this OR gate, we have two small inverters on each of the circuits. These inverters will change off to on and on to off, essentially inverting the signal. So let's say in this scenario, A is on, this will invert A and turn it to off. However, B is off, it'll invert B and turn it to on. So either or, only one of the circuits needs to be on for this to work. And so this OR gate also works as well. And since both OR gates work, this AND gate will work as well. For the AND gate to work, we need both inputs in order to work. For the OR gate, only one needs to work. And for this one, we can see in this scenario, we turn B on, the same thing happens. Since B is the only input on, as we can see here, this OR gate is lit up. This OR gate with inverters is lit up, and thus the input, and thus the AND gate is also lit up, and thus the output is also uh, turned on as well. However, we turn both on. As we can see, due to these both inverters, both gates are turned off, making the OR gate turned off as well. And the AND gate is turned off because both inputs need to be turned on. And thus the output is turned off as well. And then this is the same thing when we turn off both. This OR gate doesn't work, but this OR gate works because of the two inverters inverting both off signals to on. This OR gate doesn't work because as we can see, both circuits, both inputs are turned off. And therefore, yeah, this AND gate needs both inputs to be turned on, and that's not the case. Thus, the output is off. And over here is my GTK wave. My GTK wave shows the GTK waveform of my XOR circuit. As we can see, we have wire A, which represents the first input, wire B represents the second input, and wire Y represents the output. So this is my Lab 0 presentation on the XOR gate, and this is to serve as a demo for how to use digital circuit and how to use GTK wave. I hope you guys like my presentation. If there's anything else I need to do, please feel free to let me know. All right, thank you so much.